Okay, welcome back. We are continuing our look at equivalent rational expressions, and really we're simplifying rational expressions, okay, which is essentially looking for common factors in the numerator and denominator and then canceling them out, okay, much like if you take 2/6 and rewrite that as 2 over 2 times 3, and these 2's here can cancel, leaving you with 1/3. Okay, you can do that with other more complex rational expressions too. So we'll see that here in a second, okay. So in exercise 1, all right, we are asked to reduce the following rational expressions to lowest terms. So simplify, right? Identify the values of the variables that must be excluded to prevent division by 0. So again, what will make it undefined? Okay, so let's take a look at this right here. Now, right away, the temptation might be to see that there's an x plus 1 in the numerator and denominator and to cancel those things out. But the problem here is that we have plus 2, and so we have this addition here that we must deal with first. Likewise, we have this subtraction down here that we must deal with first. If we didn't have the plus 2, and if we didn't have the minus 1, like this, if we just had this, then yes, we absolutely could cancel those x plus 1's in the numerator and denominator since it's one big product. But with these plus 2 and the minus 1, we have to do some more work. We have to expand this out. So we'll distribute the 2. So we'll get 2x plus 2 plus 2 over, we'll have to FOIL this out here. So it'll be 2x times x, 2x squared, 2x times 1, 2x, 3 times x, 3x, 3 times 1, 3, and then the minus 1 as well. Okay, now we combine in the numerator 2x plus 4 over 2x squared plus 5x plus 2. Okay, after we combine our like terms there. And now we'll see if we can factor. Okay, so this we can take a GCF of 2 out, so we'll have 2 times x plus 2. And the numerator, well, let's see here, we can have a 2x and an x. And let's see here, can we make it, yeah, we can put a plus 2 here and a plus 1 there. Okay, you can also use the AC method here where you do, you know, a times c, there's your a, there's your c right there. And it'll give you 4, and you need two numbers that multiply to make 4, but add to make 5. So two numbers that multiply to make 4 would be 4 and 1. And so you can do like the 2x squared plus 1x plus 4x plus 2. Group the first two, group the second two. Take an x out of the first group. Take a 2 out of the second group, and then factor out 2x plus 1 from both, and you're left with an x plus 2 behind, which is then what we get right there. Okay, now you can see something in common, right? What can we cancel out? The x plus 2's. And so our final answer then would be 2 over 2x plus 1. Okay, again, don't cancel these 2's out. We can't do that because it's 2x plus 1. Okay, so that plus 1 doesn't allow us to cancel out these 2's here. We have to stop here. Now, we also need to identify the values of the variables that must be excluded to prevent division by 0. Okay, we don't look to the simplified one. We do not look to the simplified version in order to determine those zeros. We instead look at the unsimplified version here. So we need to see when this denominator will equal 0. So we'll set the 2x plus 1 equal to 0. We'll set the x plus 2 equal to 0, and just solve to see what values would make them 0. So for this one, it's going to be x equals negative 1/2 when you solve it out. And for this one right here, it's going to be x equals negative 2 when you solve it out. So in other words, we do not want x to equal negative 1/2, and we do not want x equal to negative 2, or else this would be divided by 0 here. Okay, or undefined, or 0 divided by 0 kind of thing. All right. Let's take a look at another one. All right, letter B, we need to factor this as well. It's already ready for us to factor though, so that's nice. In the numerator, we can just do the product sum because we have the lead coefficient here of 1. So we can just look for two numbers that multiply to negative 6, but add to make negative 1. And that's going to be x minus 3 and x plus 2. And then in the denominator, we have a GCF we can factor out. What's the GCF we can take out there? We can take out a 5 and an x. So leave behind an x and a plus 2 there. And again, we see common factor there, and we have, again, a product in the numerator and a product in the denominator, so we can go ahead and just cancel these two things out, leaving x minus 3 over 5x. All right, and again, we need to decide what x values would not work here. So we want to set each one of these factors equal to 0. And x plus 2 equals 0. So we get x equals 0. Oops. x equals 0 because you divide both sides by 5 there. And here, when you subtract 2 on both sides, you get x equals negative 2. So we don't want x to be 0, we don't want x to be negative 2. Those would cause us problems. All right, let's do one more here, letter C, and then, actually, no, I'll save letter C and D for the next video. So, see you next video.